of the data communication and networking. So error detection. Before error detection, we want to know what is error first. So we should understand what kind of errors we can obtain during the transmission of the data and what are the types of the errors available. So errors are nothing but when the data are transmitted in the computer network, these errors can occur and the data can be corrupted during the transmission, because while transmitting the data, unreliable transmission medias are there, and if we are getting any kind of disturbance in the original data, then we say that the transmission errors. For reliable communication, error must be detected and corrected. So always whenever two parties wants to communicate through the network, so they should use the reliable communication, and even though also error must be detected, what kind of error is there in the data should be detected and that should be corrected for the reliable communication. So this is the responsibility of the both the sender and the receiver, and we have the concept of error detection so that we can detect the error, and after detection only we can correct the errors also. Error detection and corrections are implemented either at data link layer or at the transport layer of the OSI model. So we already studied OSI reference model in the previous sessions, and we know that there is a data link layer and the transport layer. Both these two layers are responsible for either correction or the detection of the errors. Coming to the types of errors. So if the signals is carrying the binary data, there can be two types of error which you can see on your monitor screen. The types of errors are single bit error and burst error. When we talk about the single bit error, only one bit in the data unit has been changed. Suppose if we are sending the data and in the set of bits, only one of the bit gets changed or one of the bit gets affected, then we say bit error. You can see in the figure the sent data is 00000010, but at the receiving end, when receiver receives, is receiving 00001010. So here this 0 is changed to 1 at the receiver end. So if we are sending this original data and this original data gets changed at a receiver end, when receiver receiving the data, one of the bit gets changed, then this kind of changes are called as single bit errors. Similarly, coming to the burst error, it changes two or more bits in the data unit. So when more than 2, or we can say or more than 2 bits get changed, then we say burst error. Now you can see the example also. So this is the sent data 0 1 0 0 0 1 0 0 0 1. So now you can see this yellow part, the sent is 0 0, but now it is changed to 1 1. Again this 0 is changed to 1 and rest of the 0 1 remains the same. Now how many bits are changing? 1 2 3 bits are changing, but we have said that the length of burst error is 5 bits because started here. So change started from this bit and it is ending at this bit. Totally how many bits are corrupted? Totally 5 bits are corrupted, this starting point to this ending point. So therefore we say that the length of the burst error is 5 bits, right? So the length of the burst error is 5 bits. So how to detect the errors? So there are number of techniques are used for the transmission error detection and correction purposes. And error detection means to decide whether the received data is correct or not, right? So first we need to decide whether the received data is correct or not. How we can decide it? By detecting only errors, okay, not without having a copy of the original message. If the receiver is detecting the sent data is something different than the received one, some bits get changed, then we can detect the error. So message is in the error. If the sent original message is the similar one, the received one is said to be that the received message is the correct one, there is no error, detection occurs. To detect or correct the errors, we need to send some extra bit with the data. So while sending from the sender's end, we need to send some extra bit with the data so that we can understand whether the bits are corrected or not, whether the errors are occurred during the transmission or not, we can understand. So the extra bits which are sent along with the data are called as redundant bits. Now you can see how you can add the redundant bits. So this is the sender end. Let me show you. So this is the sender, right? So this is the sender who is sending this message, okay, sending message, and using the algorithm he is generating the bits. So generating the functions, it is generating some bits. So these bits are called as redundant bits, right? So redundancy check bits. So these redundancy check bits are added along with the data. So this is the original data what we have, and this is the redundant bits which is added along with the data. Now this is received by the receiver. At the receiver end also there is a function, there is an algorithm which checks whether the received data is correct or not. There is a redundant bit. Along with this redundant bit, this check function or the algorithm at the receiver side checks whether the bits get changed in data or not. So this is how we can use this error detection method to detect the errors by using the redundant bits. So after the detection only we can make the correction, right? And the correction can be handled in two ways. Receiver can have the sender transmitted the entire data unit, and second, the receiver can use the error correcting code which automatically corrects the certain errors, not all the errors, certain errors, saying certain errors, okay? So not all the errors can be corrected here. Now error detection or correction. So how it can be done? Now what happens when the sender sends the message? So generator which generates the redundancy bits. So message and redundancy both are transmitted through the unreliable transmission media from sender end to receiver end. When the receiver receives this received information which contain message and redundancy bits, now checker of the receiver end will check the received information if it is correct or not. If it is correct, it will receive the message, it codes the message, otherwise discards the message. So error detection techniques. So we have variety of error detection techniques. So there are 4 major types of redundancy checks are used in the data communications are vertical redundancy check, longitudinal redundancy check, and checksums, and the 4th one is cyclic redundancy check. So vertical is called as VRC, longitudinal redundancy check is called as LRC, and third is checksum. Fourth one is cyclic redundancy check, which is called as CRC. So this is all about the errors and the types of errors and error detection and correction. So all these error detection techniques we will understand in the upcoming video. So we will discuss one by one all these 4 types of redundancy checks. So I hope you understood this concept. If you have any doubts, please write it in the comment box. And for more videos, kindly like, share and subscribe my channel. Thank you.